Hi and welcome to Geology. So today we are going to be discussing our relative age activity where we are going to just look at how to sequence and put these layers into a order of sequence from oldest to youngest. And so we're going to be looking at a couple of different scenarios, what we're going to call cross sections, which is just a small blip of a bigger type of environment. And you can see that right here, relative age dating of geologic cross sections. And so up here, this is a whole bunch of information that you don't really need. We're going to jump down to here. So in your CAMI document, go ahead and do that. So once again, the purpose of this activity is we're going to just learn how to sequence geologic events from cross sections of strata. And we will try to figure out what's actually happening in these geologic sections. And so you can read through that if you'd like to. We're going to be once again looking at the principle of superposition, which is a sequencing of underformed sedimentary rocks from oldest at the bottom, youngest at the top. Our principle of horizontally, which is just layers of sedimentary rock are going to want to be laid down like pages in a book, layer by layer by layer. Something that we didn't talk about, but we're going to get to, is the principle of faunal succession, meaning that looking at plants and animal fossil records to kind of help us figure out, like, if there is a T-Rex bone in that rock layer, more than likely it formed quite a bit ago, not so more recently. And then the other two that we talked about, the principle of cross-cutting, when you have a fault and or an igneous intrusion that cut through, and then our intrusion. And so let's just kind of take a look. So this is our cross-section here. This is what we're going to be looking at. And as you can see, there's quite a few of them if we move on through. These are all different, those figures are different cross-sections. So the first one here is what we're looking at, or what they're going to be asking us to do is list the layers in order from oldest to youngest. So we kind of start out easy here. We can see that we just have a visual of our horizontal layers. So sedimentary horizontal layers, we've got A, B, C, D. Oldest layer is A, and as we move up, D is going to be our youngest layer, and that's what it's kind of talking about right here. However, most layers, this is kind of what Kentucky looks like, to be honest. They're pretty flat. However, that's not always the case, is that we can get different types of formations in there. So if we take a look here, you can start to see that we have some folding. So some type of plate tectonics happen between layers A, B, C, and D. And then you can see that squiggly line there. That's what we called that non-conformity that we talked about, is that there was some kind of erosional process that more than likely this layer continues up over here. This layer continues here, and D probably continued up here. It was eroded, it was erased down, and then layers E and F were formed on top of it. So if we look at it and think about it, our oldest rock layer is going to be A, followed by B, C, and D, and then we have our nonconformity, and then E and F. F is going to be our youngest layer. And you can read through that if you'd like to. So we're going to use this key to kind of help us with some of our rock choices here and kind of ordering them out. So you might have to refer back to this chart just a few times, is that it is broken into our different types of rocks. We've got our sedimentary, and as you can see, this key right here is going to be conglomerate, sandstone, siltstone, shale, limestone, and limestone, a couple different types of limestones. Then we have our igneous rock, granite, and basalt, and then gneiss and schist. And when we see this squiggly line here, that's an unconformity, normally going to be a non. We can also have our faults, and then our contact metamorphism. So we're going to jump down. Let's just do figure number 1 right here. And so I'm going to grab my pen. I'm going to write in red today. So once again, we're just looking at what are the oldest to the youngest, and let's not forget to recognize A here. This is our igneous intrusion, our cross-cut. So when we're looking at this, we just have to kind of think like this is our youngest because it's cutting across almost everything else. So if it touches all the other layers, more than likely those other layers had to be there in order for A to come in and cover over top of them. So our oldest layer is going to be C, followed by then A still cutting over top of that, so E, D, B still, because you can see A cut across over there, so B and then A is going to be our youngest. And I'd like for you, if you can, to kind of like talk about what some of those are. So A, I would want you to say, I'm going to use a text box for this will be easier, is our cross-cutting or igneous intrusion. That is really, really big. Let's see if I can make that font a little bit smaller here so that it doesn't take up everything. There we go. Kind of want it right next to A there. Yeah, kind of get the idea. But everything else, these are all just sedimentary rocks. You can go back and look. I think this was our conglomerate, limestone, sandstone, another conglomerate, and then our granite intrusion. So simply, once again, just looking oldest to youngest, kind of incorporating. They get a little bit more challenging as we go through. Let's take a look at number 2, or figure number 2. So once again, we've got a couple of different things going on here. This one looks a little bit different. So we need to probably go back and take a look at our key to look at what E and B are. I can see, if I remember correctly, C, D, and A, and since they're in horizontal lines, I know those are sedimentary rocks. But right off the bat, B, I can tell, is an intrusion because it's cutting over E. Looks like at one point it probably went up even higher and C came down in a road. So we have a non-conformity right here. But what is this layer E? Let's go take a look. See, that's going to help us. So E is granite too. So a metamorphic rock, and then we also have an igneous rock there. So we've got basalt and metamorphic. So we can tell more than likely that E somehow came in contact with C here, but we don't really know which one came first. I'm going to assume more than likely E, since it's here down at the bottom. So we're going to say E is still the oldest. And then if we take a look, we can see B is it's an intrusion. We can see that it's one of those big non-conformities that's come into contact over E. And we can see that it probably at one point went up higher right here. You can kind of think about it probably going up higher, but some kind of erosional process happened right along this right here. And so more than likely, then we can say that this was eroded down and then C came and deposited over top of it. And then clearly we can see that straight, horizontal. So then D and A. And so then even, let's go back and kind of just fill in some pieces of information here. Is that E is metamorphic, and B, more importantly, is that non-conformity. We can see that non-conformity right there. You can even label it right here if you want to, non-conformity. I think it's also important to label this one as our disconformity. So that we know that that's kind of happening. So you can use those terms. I know you can't really see that very well there. Move it right there. So here's what I'd like for you to do is I want you to go through and try figure 3, figure 4, and as you can see, we're starting to get a little bit more difficult. These are our faults here. So remember, the fault comes after the rocks are put in, just like an intrusion would be. That A and C had to be there before B. Let's give you the answer to that one. But our faults had to be there. So more than likely A connected here and here. This layer connected here, this connected here, and then the fault came in and caused this layer to slide down. Once again, cross section. So we're only looking at a small dip of it. And then number 5 is really, really challenging. So see what you can figure. Don't forget also to add in those nonconformities, the disconformities, and our angular conformities. So like what's kind of happening with some of them. So I'd like for you to go ahead and try this, and then when you're done, submit, and we'll kind of talk about it a little bit more. Hopefully this was helpful.